Ed eccoci qui dopo il primo speech, devo dire molto interessante. Claudio, questa sì. Però è materia tua, sono cose che mastichi tu. Grazie Fabio, se volessi accomodarti con noi, non so se...
Ciao.
Durante questo intermezzo, come dire, sì,
è materia che mastico io e che fa sempre comodo rinfrescare e scoprire tecniche nuove, perché oggi abbiamo, cioè, lo scopo di un analista vede quotidianamente stare a detectare tutto quello che durante sto talk abbiamo visto come non farsi scoprire.
Esatto, giustamente abbiamo visto, diciamo, il lato red. In realtà sta già per iniziare il secondo talk, non ho il tempo di scambiare due chiacchiere, però ecco, abbiamo visto alcune tecniche di offuscamento, no? Di evasion, analisi statica, analisi dinamica. Magari se c'è qualche appunto magari ce lo prendiamo anche con la nostra chat, dopo cerchiamo di discuterne un pochino.
Molto volentieri. Io darei parola al prossimo talk che sta per iniziare praticamente.
Esatto, e parliamo di API crypts, vedo. Ok, esatto. Vediamo un po' che cosa ci dice, ci rivediamo ovviamente qui dopo lo speech.
Regulation, tech related, and is called ᴘᴜᴅᴅᴛᴜ. I'm also an independent security researcher. My research interests are mainly, obviously, API for IoT devices and web application security. You can find me on Space Current site on Vangelis Stykas and on Mastodon as Vangelis Stykas at the InfoSec Exchange, and this is my personal website, stykas.com. Let's start with what is an API. I really like MuleSoft's definition of what an API is. It's the acronym for Application Programming Interface, which means that it's a software intermediate that allows two applications to talk to each other. Usually, people shouldn't see APIs, but yeah, we are going to see a lot of APIs in here today. My definition is that an API is an easy way to interact with a DB layer. You write the API once and you use it everywhere. You use it in multiple clients that you can see, mobile devices, enterprise application, TVs, games, pretty much everything that you see. And Sims Complex has an API. There's another really interesting API to API connection that was used a lot in Twitter. Unfortunately, in the past week, they have decided to disable API to API connections, so this is not happening anymore. In that, I had a nice example for Twitter API to API connection, but it's not here anymore. Well, APIs are really easy to build, but they are really difficult to build them securely. The type of APIs that we are going to see in here is first the REST and foremost GraphQL, which is the new kid on the block. It's Facebook query language API. SOAP, which is a really old implementation that XML was actively enforcing, and I'm really happy that it is dying, and the non-standard APIs that are being used by a lot of devices. First of all, it's the REST API, which is CRUD. By CRUD, we mean the create, read, update, delete. You're going to see it on the right side that the create is post, the read is get, the update is put, and delete is delete. Those are the verbs. They're really easy to identify. It's the most common APIs that we see right now. The recent study said it's about 65 to 70% of the APIs. It's easily predictable because it is uses entities. So if you have seen enough APIs, you can usually guess what they're doing, what are the entities, how you're going to create something, or how you're going to delete something. Then it's GraphQL, which is again easy to identify, but really trickier to read. It needs some reading on the specifics so that you can get used to it. But after that, and after understanding the custom query language, it's super easy to enumerate. It has introspection, which some companies have them enabled. And if a GraphQL API has introspection available, it's really easy for you to do a lot of strange and bad stuff. It returns JSON, but not the nice JSON that REST APIs has. It's something totally different. Next is SOAP API. I'm not going to use a picture for it because I just hate it. It's really old school. It returns XML. It has an envelope format, which means it has a header and then a body and then another header. Microsoft used to use it by a lot. It had WSDL and SOAP, but thankfully it's moving away from it and starting to using RESTs. Custom APIs can return everything or anything or all of it. It's being used either via WebSockets or random HTML requests. It's being used extensively on proprietary devices, medical devices, and other IoTs. That thing that says JSON in XML in JSON is unfortunately true. You're going to see a lot of XML in a lot of JSON in a lot of other places. And when you try to understand what it's saying, you just have a terrible headache. Documentation on APIs are either freely available, so a well-documented API can give you a better understanding of the structure of the API and how you can interact with it or how you can make it do things that it shouldn't, or you can find a forgotten documentation, which is usually a gem that you are going to use on your attack vector. Now, where APIs are used. They're used in IoT devices, they're using in web application, they're using mobile application, they're used pretty much everywhere. Industrial IoT, vehicles, pacemakers, you name it. If it is something that has an internet application, an internet connection, it probably is using some kind of API. What we can do with APIs and attacking APIs? Usually when I started like 7 years ago, everyone was saying, yeah, it's just APIs, you cannot do a lot of things. I have proven that you can gain full functionality of IoT devices. You can make them do unintended things. You can make them burn, which is an interesting thing that an IoT device can do. You can punch through firewalls. You can pivot to internal networks, and you can reflash them and potentially make them a break. You can also do SMS attacks. If there is an SMS vector, you can make them a botnet. You can do ransomware attacks as you are inside a potentially unreachable network, and you have no need for SODAN because we are talking about cloud, so you just interact with all the devices. There is a special place for what the Chinese clouds name API sharing. So a lot of the Chinese clouds are using API sharing. So they have a unified API for a lot of their IoT devices. And when you hack a bathtub, you end up with root in medical devices. I have seen that. I have published that more than once. You are owning a device and you are ending up with a totally different class of devices. A special category that I really like is industrial IoT, because historically they're isolated. I see that we have an IoT talk later. They're isolated, they have a long lifespan, so there are IoT devices in there that are older than me, and I'm 40 now. They're rarely updated, they're safety critical with a high uptime, their protocols are usually unencrypted, and making it smart means that usually they have an IP to RS-232 M2M, which you end up on a device that just gets RS-232 commands from internet, and that rarely goes well. Yeah, Mikko Hyppönen said, if it is smart, it is vulnerable, and we're going to see that this is the case for a lot of devices. So what's the plan for the talk? We're going to see the severity, we're going to see the exploitability, and we're gonna see how we own most of the devices. Unfortunately, I'm gonna be bad in here. I have deleted a couple of exploits because they're still 0-day, and I would prefer not to end up in jail. So what are the vulnerabilities of APIs that we're going to see? Number one on OWASP API top 10 is IDORs or BOLAs, insecure direct object references. Number 3 is information disclosure, and that's usually when the API returns everything when you shouldn't. So think about Amazon. If I say, can you give me my phone number? And Amazon API gives me everything that I have ordered in the last 20 years, and the client is just filtering it. It's probably not a good idea and not a good design. The other thing is authorization issues, which we are going to see that a lot of APIs, they think that authentication means authorization. Those are two totally different things. It's injections, like we're back in the 90s, we're going to see that a lot of APIs also have SQL injection, XSS, and business logic flows, which is my favorite one. It's making APIs do things that they shouldn't. I have to have a legal disclaimer in here. CMA in crime alert. API research is really tricky. Never, ever, ever interact with a device you don't own. If you mistakenly do it, please notify the vendor immediately. Getting platform admin means that you're breaking CMA. CMA is the law in the UK, which means Computer Misuse Act. Anything that is in red in the following slides is breaking the CMA. So I have a good lawyer. If you don't have, don't do it. First is classic IDOR, as we said. You have to learn that authorization is not equal to authentication, or API issues will come after you. So it's the easiest of all of them to find. You just see the ID, you press +1, -1. If you see data in there that you shouldn't see, this is a typical IDOR. Typical symptoms of missing authorization and just having authentication. GUID is not a solution. GUID could be predictable. You shouldn't depend on GUID. You should have proper authorization. It could lead into leaking a full data set. First example is the Viper Smart Alarm. You can see on the highlighted parts that, unfortunately, it's on top. You can see that you could use a post request to update any user. You could just change the password or the user email and end up with remote control of any vehicle, alarm functions, identify vehicle and geolocate it in real time. So you could find a Ferrari in here and unlock it and steal it. You could stop the vehicle. You can panic alarm and pop the trunk. Second is one of my favorite IDORs. It's Project EV. That's an EV charger. You're going to see that the only thing that it had in there is a charge ID. There's not even authentication. So you could just randomly start unlocking, stopping, lock and lock, remote firmware update, backdoor, pivot into the internal network of the company. You could break it. You could take platform admin in there just from that single request, unfortunately. Or fortunately, how you say it. Again, learn that authorization is not equal to authentication, or you're going to have a really big problem in here. Injections. We want to state that the next 3 slides are all breaking the CMA, so don't go and do SQL map into random websites. The good thing is that there's an automated ways of finding them. It's called SQL map, it's called burp. Don't go and do unauthorized scans in random websites. They are nowadays really rare because we have ways of defending around them, and it could lead to RCA. This was on my talk of BSides London. It's the Truth Spy. They had an SQL injection, and I'm not going to say what the SQL injection is because it's still there, and it's all red. You could remote control all the monitor devices. We're talking about 500,000 of devices that were actively monitored. You could link the full data set and the images from there. You could RC on all the servers. And if you are a good person, you could possibly identify a crime syndicate and go to the FBI that will be after them, I guess, or after me, I'm gonna say. How you can defend against injection? Use a modern framework. For the love of God, don't use just PHP and ASP. Sanitize your inputs. Keep the principle of least privileges. Don't run your databases as root or SA. Do not share database or credential between your projects because you will end up being owned massively. The third one is the lazy REST implementation. You need to check response and request. It's a typical symptom of using an ORM lazily. So the ORM is mapping the full object to the database. You always need to check for allowed parameters on user input, and you could lead into platform admin. A really nice charger, EV box. You can see that I could patch my own user, so they had authentication, but I could add any role that I wanted. So the role that I wanted was account owner that I already had, admin, and the tenant admin that the whole system, when I added a role 1, it said, do you mean tenant admin? So I said, yeah, well, heck not, I mean tenant admin. Why wouldn't I want tenant admin? It ended up with all admin functionality, platform admin, server admin, RCE, because tenant admin means I could run commands anywhere on the tenant, PII leakage, and total compromise of everything. How you can defend about it is check response and request. I think I have read that before, right? You need to check what you're doing. You need to whitelist, allow list the parameters. You shouldn't accept anything that is not expected, and don't accept just lazy ORM implementations. Another lazy REST implementation is one from the kids' watch that was with Troy Hunt's daughter. You can see that there is a family identifier in here that's proper queries. So if you change the family identifier to something else, you could see in here that you could actively see where it was. You could change where your kid was, and you could end up, I don't know if we have listening here. Do we have sound? This is Troy Hunt's daughter. She was there in Australia, and I was just calling her from Greece, creeping her out because I have a really creepy accent. And I also, she's talking to me here, and I'm saying in creepy accent like I'm Vangelis from Greece, from the other part of the world, because, yeah. And during that call, I also faked her location to be with me in Greece. That didn't ended up really good with Troy. We had all admin functionality, also platform admin. We took total compromise of everything and could change all the locations of the devices. If possible, avoid using functions that automatically bind the client's input into code variables or internal objects. Whitelist everything. Don't trust any of your inputs. Explicitly define and enforce schemas. Don't try to use anything automatically generated from a framework if you don't know exactly what you're doing. This is my favorite one. It's user group juggling. I really like changing user groups. There's multiple potential ways of user group juggling. When I see a web application that says add the user to your group, I really like it because I want to add a user to another group. Sometimes create is not vulnerable, but edit is. So you just add it on your group and then try to change it to another group and then to an admin group and then being a total admin. It could lead to platform admin or accounts takeover. The first one example is ᴪᴜᴜ. You can see in here that I was able to just change the group ID and have access to any ᴪᴜᴜ in there. which is routers, firewalls. I could change VPN. I could take the security reports. I could take the traffic analysis. I could literally get SSH access into the internal network and do a ransomware attack. Don't do that. Never do that. Web application firewalls. You practically had admin on that company's software as a service provider from ᴤᴜᴜ. Another one is, I really like Mimosa, not the drink, the antennas. Again, you could just go in there, post to a user ID with a different ID, so you can see that's 1, 2, 3, 4, and the ID is 1. And you could link everything. You can access, again, the internal networks. You had SSH access. You could have full organization access. And again, the same thing, ransomware, don't do that. You have a lot of potential without using shutdown or any kind of, I don't know, red teaming, mumbo jumbo that I don't really understand. Totally respect, but I don't understand because I'm dumb and simple. You should never be lazy and always check for correct authorization. Again, don't do it, especially on user access functions. See that the user that you want to add has access to where you want to add. Second level IDOR, it's one of those IDORs that the first parameter is correctly authorized and you're like, oh, they're one of the goods, they know authorization. And then you have a second level and that doesn't have authorization. So the fact that there is a check on the first level does not mean it's everywhere. You should always check as an attacker all the parameters, check every combination possible. It could lead into account takeover. Another EV charger, wallbox. It had the access configs on the top, had a proper authorization check, but the chargers didn't have any authorization check. So I could take all the chargers and put them on my access config and have access to all the chargers and total control over all the chargers. I could lock and lock. I could take the PII of every user. I couldn't, unfortunately, firmware update them, but I consider it a win still. The last one is REST verb juggling. So read the REST principles, try to change if something is getting, try to post it, try to put it, try to guess what function would not be implemented and see if you can override that. It could lead into platform admin and account takeovers. Unfortunately, I cannot talk about the API that had that vulnerability because they still haven't fixed it for 7 months. So no 0 days for you, unfortunately. Again, never use the full control URL mapping unless you know you will need everything. Disable the functions that is not needed. If you don't need to update the user, disable the patch, disable the delete, and always check for proper authorization. Hide the endpoints. So you should read the JavaScript as the attacker or the Android source and see for endpoints you don't see in your interactions. What I usually do, I have a Python script, which is not AI, but I'm going to say AI for it, is take the burp request for after using the application, then parse the Android source code, extract the functions, and see what have I missed and what I haven't seen. More often than not, I can see hidden endpoints that have functionality that is either disabled or admin related. You should use automated tools. You should try to think where corners were cut from the developers. It could lead to a lot of nasty stuff. One of the things is a car alarm that I have taken care of. It was called Pandora. They said they weren't hackable, so yeah, they weren't. Long story short, they had a hidden endpoint that when a newcomer, a new worker was onboarded, they were said, create the user, and then we're going to upgrade you. They had that JavaScript in there. So yeah, I just upgraded my own user because why the heck not? So I could geolocate any vehicle, I could unlock it, I could stop it. I could listen to someone from the internal microphone. I don't know why the functionality was there, but I could have it. and I could potentially profit, that should also be in red, because I cannot see of a non-criminal way to profit of that. The other one is a really strange, what was the name of the SE tracker, of a tracker device for your kids. There was a JavaScript file that was named backup.js. It was referenced by a map. I ended up with all the source code because that backup.js was zipping everything into a zip file. So I downloaded and read the code. They had static keys, SSH password, database configuration, everything, full RC on 40 servers, and all the devices info. We're talking about a million of devices of children's watches. What you could do is geolocate any device, use it to send SMS and phone. I usually say that if I have enough phones, I can win Eurovision. I don't know why it makes sense, but people like it. You can listen to someone from the microphone, and those someones are usually minors, so this is also a big crime. Another hide-there endpoint is on an EV charger that they had the GraphQL introspection available, so you can see everything for everything, you can interact with everything. We can stop a car charger, you can charge for free, go there and charge someone else as you could unlock the device. PAI was obvious. I could see all the users' data and where they were and where they have charged last time. I couldn't see any CC, thank God for that, but anything else could be queried. For the hidden endpoints, keep in mind that people will look at your devices, will decompile your application, they will have to be brutal with you. You always have to verify that the hidden endpoints has proper authentication and test for broken workflows for both automated and manual. So whatever you do, you have to do it as another user. You have to change your cookies. You have to then check on admin functions as the user, on admin functions as a non-admin user, etc., etc., etc. As general recommendations, it is critical to authorize all your requests. Authentication is nothing if you don't check that the request is correctly authorized. Rarely, only once I have seen something that is nothing is authorized. It's usually 1, 2, or 3 requests that have been forgotten, but they're often more than enough to get everything. Never, ever, ever trust user input, and check that every request is authorized once and for all. Any questions? Thank you.